Hey, before we go on to some more practical examples, let's produce a dendrogram. There are several ways to do that, most commonly using the SciPy dendrogram, but here we will do something a bit different. It is still using SciPy in the background, though. I am talking about Seaborn. Yes, we've used Seaborn's beauty for long enough without taking advantage of its power. Well, that is about to change. Let's import all the conventional libraries. The data for this lecture is in the Country Cluster Standardized CSV. Let's load it. I will also add an argument, index col equal to country. This will automatically use the entries from the country column as indices of the data frame. Next, I'll put the data into xScaled, drop in language from it as we won't be using it. All right, that's what's inside xScaled. Nothing new. It is time for the Seaborn magic. Let me write the code and we will interpret it later. SNS dot cluster map brackets xScaled. And that's all. Seaborn is a really easy library to use, should you know the exact feature you need. Okay, the result is a bit overwhelming. I'll change the colors to a color map I like better, called Mako. Sorry if you preferred the first one. Let's explore the result. Here are the two features, latitude and longitude. And here are the 6 observations. On the left side is the dendrogram, the exact same one we used in the previous lecture. So, Seaborn has clustered the observations in the background. Pretty cool, right? Yeah, that's how I would usually go about creating a dendrogram should I need one. At the top, we see this rectangle-like shape. In fact, it is another dendrogram, this time uniting the two features. In the same way, we can cluster the observations, we can reduce the dimensionality of the problem by combining the features themselves. That's going to be the topic of the next section, so let's wait until then. Finally, let's address the elephant in the room, all these pretty colors. This is called a heat map. At the top left corner of the graph, we can see its legend. Values around 1.6 are bright, around 0 are bluish, and turn black at around minus 1.6. Okay, let's start from latitude. Most colors seem alike. Only Australia is different. That's because on the world map, the latitude of the other 5 countries is very close, as they are all in the northern hemisphere. Australia is the only one in the southern, so the color is completely different. In terms of longitude, Germany, France, and the UK are very similar. Australia is extremely bright, while USA and Canada are purple. Given the legend, we can tell that Canada and the USA are close to each other, but different from Europe, and completely nothing like Australia in terms of longitude. Heat maps in general are a great way to explore the data. We can even cluster these observations just by looking at the colors. Germany, France, and the UK are very similar regarding both features, so they will be one cluster. USA and Canada almost the same in terms of longitude and have a slight difference in terms of latitude. Australia is completely different in both aspects. So, these are the 3 clusters based on the heat map. That was easy, wasn't it? What if we want a 2-cluster solution? Well, that's even easier. Australia is the outlier. It has completely different colors from the others. You can read more about Seaborn's cluster maps in the link provided with this lecture. There are many ways to customize them. The most important one is choosing the method of hierarchical clustering. As I told you before, Ward's method is the most common one, but it is worth exploring the others. All right, your homework will be to take this new knowledge and practice it on the market segmentation problem. Create dendrograms, observe heat maps, and prepare yourself for the practical example. Thanks for watching.